All right, let's dive in. Today, we're going to demystify a term you hear everywhere, from sci-fi movies to your own smartphone: machine learning. It's kind of this invisible engine that's shaping our world, and in the next few minutes, we're going to pull back the curtain and see exactly how it all works.
So, let me start by asking you a question. What's the invisible thread that connects the movie Netflix just recommended to you, that fraud alert you might get from your bank, and all that junk mail that, thankfully, never even makes it to your inbox? I mean, they all seem like totally different things, right?
Well, the answer to all of it is, of course, machine learning. It's this incredibly powerful technology that's just humming along silently in the background, making countless decisions for us and about us every single day.
So what is it really? At its heart, machine learning is a specific, really powerful branch of artificial intelligence. Think of AI as the big overarching goal, making machines smart. Well, ML is one of the best ways we have to get there. Instead of a programmer writing endless if this then that rules, we build systems that actually learn from data, from experience. It's kind of why all machine learning is AI, but not all AI is machine learning. You know, an old chess program with rules that were all hard-coded by a person? That's AI for sure, but it isn't learning.
And the crazy thing is, you really don't have to look far to find it. Machine learning has quietly become this invisible yet totally essential part of our modern world.
I mean, just think about it for a second. That "you may also like" suggestion when you're shopping online? Yep, that's ML predicting your taste. The next show that pops up on your streaming service? ML again. It's what spots weird behavior to flag potential credit card fraud. It helps doctors find tiny anomalies in X-rays. And yeah, it's even what big financial firms use to try and predict where the stock market is going. It is, quite literally, everywhere.
Okay, so how does a machine actually learn? It's not magic, not at all. There's a playbook, and it usually breaks down into a few main strategies.
So the two most common ways are supervised and unsupervised learning. Think of supervised learning like studying for a test with the answer key right in front of you. We give the machine a ton of labeled data, like thousands of emails that are already marked as spam or not spam, and it just starts to learn the patterns, to tell the difference. Unsupervised learning is the total opposite. It's like we give the machine a giant, messy pile of unlabeled data and just say, go find something interesting. This is exactly how a streaming service can discover these hidden groups of viewers with similar tastes and then recommend a new show that you'll probably love.
And then you've got the third major type, reinforcement learning. And this one is all about trial and error. Imagine teaching a computer to play a game like chess. It makes a move. If that move puts it in a better position, it gets a little reward, a point. If it makes a terrible move, it gets a penalty. Now do that millions and millions of times, and eventually it learns the absolute best strategy to get the most rewards and win the game.
So, we have these different ways machines can learn. But how do we get from that concept to a real-world tool that can actually, do something useful? I absolutely love this quote because it just nails the whole process. An algorithm, that's the general set of rules. It's the recipe. But when you take that recipe and train it with your specific ingredients, your data, the result is a model. So the algorithm is the recipe for chocolate cake, but the model is the actual cake you baked.
And the process to bake that cake looks something like this. First, you have to gather and prepare your data. And honestly, this is usually the hardest, most time-consuming part. Then you feed all that clean data to your algorithm, and that's the training part. Finally, you have to test it. You give it new data it's never seen before to see how well it does, and if it's good enough, you release it into the wild.
Now that we get the basic workflow, let's do the fun part. Let's peek inside the data scientist's toolbox and check out a few of the most common algorithms they use.
Just like a carpenter has different tools for different jobs, a data scientist uses different algorithms for different tasks. The two big ones are classification and regression. Classification is all about sorting things into buckets. Is this email spam or not spam? Yes or no? Regression, on the other hand, is about predicting a specific number, like what's the price this house will sell for, or how tall will this kid be?
And here are a few of the tools themselves. A decision tree is basically like playing a game of 20 questions. It asks a series of simple yes-no questions to get to an answer. Clustering is what you use for unsupervised learning. It finds natural groups in your data, like separating online shoppers based on what they buy. A random forest, well, that's like taking hundreds of those decision trees and asking all of them for their opinion. Then you take the most popular vote. It's way more accurate. And then you have neural networks. These are the heavy hitters, inspired by our own brains, and they're the powerhouses behind things like image recognition and even self-driving cars.
But look, it's not always a smooth ride.
With all of this incredible power comes some really significant responsibility and some major challenges that we absolutely have to talk about.
And that interest in this field is just exploding. I mean, to give you some sense of the scale here, one academic journal called Machine Learning saw 1.9 million article downloads in just 1 year. This whole field is moving at an unbelievable pace.
But that speed creates problems. First, there's the old saying, garbage in, garbage out. A model is only ever as good as the data you feed it. Then there's something called overfitting. This is where a model basically gets an A+ on the practice test, but then completely fails the final exam because it just memorized the answers instead of learning the concepts. And then there's the really serious issue of algorithmic bias. If the data you train a model on reflects biases from our past, the model will learn those biases as the correct way to make decisions, which can lead to really unfair outcomes. And finally, there's the black box problem. With some of the most complex models, like neural networks, sometimes we get the right answer, but we can't fully explain how the machine actually got there.
And tackling all these challenges brings us right back to the most fundamental definition of what learning even is. It was captured perfectly by computer scientist Tom Mitchell. He basically said a program learns if its P performance on a task improves with experience. And that word improves, that's the whole point. If our models are just learning flawed patterns from our data, are they really improving? It grounds the entire field in a simple, measurable idea. You have to get better.
So, as we wrap this up, I want to leave you with one last thought to chew on. We've seen that these machine learning models learn directly from the data we give them. They are, in a very real sense, a mirror. They reflect our world, our choices, and our history right back at us. So the most important question isn't just what our machines are learning, it's as they learn more and more, what are we teaching them about ourselves?